Hi, my name is Susie, and I will be presenting on the drug fentanyl. General description of fentanyl. The generic name is fentanyl, and some brand names are Duragestic, Abstral, Actique, Ventura, Unsolus, and Sublimase. The chemical name is listed here, N-phenyl N. What is a drug used for? The drug is used to treat severe and chronic pain, such as chronic cancer pain, or to treat patients with severe pain, usually after surgery. When you should not take the drug. You should not take fentanyl if you have known allergies to it, if you have severe asthma or breathing problems, or if you have stomach or bowel obstruction. Significant interactions with other drugs. Fentanyl should not be mixed with alcohol, grapefruit juice, or benzodiazepines, which are psychoactive drugs. These interactions can cause serious side effects or increase existing side effects. Interesting facts about fentanyl. Fentanyl can be medically prescribed and can be administered in a variety of ways, such as injections, intramuscularly, or intravenously. They can be given as an oral spray, a nasal spray, and can be even given as a lollipop or by applying a patch to the skin transdermally. Fentanyl is 50 to 100 times more potent than morphine and highly addictive. They are the most common street drug to cause drug-related overdose death, and go by street names such as China White, Dance Fever, Goodfellas, Murder 8, and Great Bear. Here is my fentanyl drawing video. The first portion is the CH benzene ring with alternating single and double bonds. And this is attached to a CH2 and another CH2, and this is attached to a nitrogen with a lone pair. This nitrogen is attached to a CH ring with all single bonds. And then this ring connects to another nitrogen with a lone pair. And then this is attached to a carbon double bond attached to an oxygen, and then a CH2 and a CH3. This nitrogen is also attached to another benzene, alternating double and single bonds. And this is the skeletal structure of fentanyl. The next slide is the skeletal structure and expanded structure. The page 11-3 is the same fentanyl structure from the drawing video. And the 11-4 is the expanded structural formula, and it shows all the carbons, hydrogen, and nitrogen and oxygen written down. The next page is 11-5, and this is the Vespers theory molecular geometry predictions. And this is showing the molecular geometry around each central atom. This is color-coded, and it shows that the blue carbons are all trigonoplanar, all the red carbons are tetrahedral, and all the green nitrogen with the lone pair is trigonopyramidal. 11-6 is the molecular formula and molar mass. You could find the molecular formula by looking at the expanded skeletal structure, and if you count out all the carbons, hydrogen, nitrogen, and oxygen, you could find the formula C22, H28, N2O. The molar mass is found by looking at the periodic table. You need to find the molar mass of carbon, hydrogen, nitrogen, and oxygen, and multiply that by the amount of carbon, hydrogen, nitrogen, and oxygen. If you add all those together, you would get 336.52 grams of C22, H28, and N2O. The next page is the hydrogen bonding with water exercise, and this is on page 11-7. This page shows all the H-bond acceptor and H-bond donor, and you can see that the F over N hydrogen bonding would be an H-bond acceptor, and if it's a F over N without hydrogen bonding, it would be a hydrogen donor. The next page is the hydrogen bonding with water for fentanyl, and this is on page 11-8. This molecule would all be H-bond donors, since the F over N is not hydrogen bonding. So the two nitrogen would be H-bond donors, and also the oxygen would be H-bond donor. The next page is the polarity and solubility prediction, and this is on page 11-9. Fentanyl is somewhat soluble in water, which was confirmed on PubChem, although fentanyl has CH bonds which are nonpolar and insoluble in water. As you can see in the picture, there are polar bonds between the nitrogen carbon and the oxygen carbon. There is a more electronegative pull towards the nitrogen and oxygen, since they have greater electronegativity than carbon. The overall general direction of the polar bonds show polarity, and you can see that by the blue arrow. So this is a polar molecule, showing that this molecule is moderately a soluble drug. The next page is the solutions calculations on 11-10. And for number 1, you would want to prepare 50 milliliters of 2.30 times 10 to the negative second solution of my drug. I wanted to find the mole of my drug C22H28N2O. So I used the mass times liters equals mole to find the mole of my drug. Then I converted mole of C22H28N2O to grams using the conversion factor from mole to molar mass of C22H28N2O. For number 2, I used the M solute over volume solute times 100%, and I got 0.060 grams, and you would multiply that by 1,000 milligrams over 1 grams to get 60 milligrams. Okay, and here are my references. Okay, thank you.